Now we are going to learn about the motion of the connected bodies when they are moving in the horizontal direction, that is in horizontal motion. Here two blocks are there. The masses of the two blocks are M1 and M2. Here this M1 mass, it is hanging here. So due to gravitational force, it is hanging here. Another mass M2, simply it is placed on the table. Okay, simply it is kept on the table. Here the tension, it is acting in this direction. Both the two masses M1 and M2 both are connected by a string. Look at the direction of the tension. Here on this mass, the tension, it is acting in this direction. Along the string, the tension is acting here. The tension is acting in the opposite direction. This one should be taken as a point of suspension. Always tension will be acting towards the point of suspension. Here, this mass M2, because of the pull, the mass M2 will be moving in this direction. Therefore, the acceleration of the body M2 must be taken in this direction. Here this mass is pulled due to gravity, therefore acceleration must be taken in the downward direction. First you should know the direction of all the forces. Later you are able to draw the free body diagram. Now I have drawn the free body diagram for mass M2. Draw the mass M2 alone. This is the gravitational pull acting towards downward direction, that is M2G. At the point of contact, the normal force is acting towards upward direction, that is against to the gravitational force. The same tension, it is drawn in this direction. So totally three forces are acting: tension, normal force and gravitational force. For that I have drawn the free body diagram. So the mass M2 must be drawn in the form of a point. After that, the normal M2G both are drawn in the opposite direction vectorially. The tension, it is acting in this direction. Let us come to the next one. What is this M1? Just two forces are acting. One is tension in the upward direction and M1G is acting towards downward direction. So here the vector of the M1G and the tension both are acting on the point mass M1. The same mass block, it is drawn in the form of point. So we have drawn the free body diagram for both M1 and M2. Our aim is to find out the expression for the tension and acceleration. Are you clear? The two must be derived now. So let's see the analysis about mass M1. So in the case of mass M1, we will concentrate only on the mass M1. There, how many number of forces are acting? Look at the diagram. With the help of free body diagram, we are able to write. Are you clear? Tension, it is acting in the positive y direction. For everything we have to refer the coordinate system. So tension, it is acting in the positive y direction. Therefore, tension vector must be written like this. Tension J cap must be drawn in the upward direction. No, J cap. It is positive y direction. Therefore, J cap. M1G is acting in the negative y direction. Therefore, Mg. First you write plus minus J. That is equal to what? As per Newton's second law, if these two forces are added, that one will give you the net force. The net force formula is M into A. That is also a vector. So here, if both are added, you will get the total force, that is called as net force. And in the next step you write, okay, Tj cap minus Mg J cap, which is equal to, instead of F net you can write Ma. This net force is acting on the mass M1, therefore M1 must be written. Don't forget, everywhere M1 must be written. Are you clear? What about the direction of net force? Look at the diagram. It is pulled towards downward direction. Mass M1 will be moving in this downward direction. That is in the negative y direction. Therefore, this one must be written as minus J cap. Are you clear? Now, we can eliminate all J's. Just will remove the components alone. T minus M1G, which is equal to M1A. So like that we can write. Are you clear? So this is the final step of the equation. Are you clear? We will block the equation. Later we are going to use this one. Are you clear? Here the minus sign has to come here. Now we are going to derive the expressions for the mass m2. In the case of mass m2, we are going to derive the same kind of expression. Let us concentrate only on mass m2. Look at the forces. Here normal force is acting in the upward direction, m2g is acting in the downward direction. First let us see the forces which are acting only along x direction. Which force is acting? Tension is acting. Therefore, tension is acting along positive x direction. First we will concentrate on x axis. That is x axis alone we have to concentrate. Tension is acting here. Are you clear? So, tension is acting along positive x direction. No, therefore, T I cap must be written. Are you clear? Is there any force here? Nothing. No force is acting in the opposite direction. Therefore, this one will be equal to the net force. Are you clear? What is the net force formula? M into A. Therefore, T I cap, which is equal to, instead of F net we can write MA. Here the body is moving because of the net force. Therefore, it is moving in the positive x direction. Therefore, we can write it as I cap. Remove this 2 I cap. Therefore, T will be equivalent to MA. Are you clear? T will be equivalent to how much? MA. So, here we have got the expression for T. Just you block this. Are you clear? Now, so this is in the case of x direction. Now, we have to look at the y direction components also, y direction forces also. I will write the y direction components here. The normal force that is acting in the positive y direction. Therefore, we can write it as N J cap must be written. M2G is acting in the negative y direction. Minus of, first you will write plus Mg that is acting on M2. Are you clear? Here also M2 has to come. We are concentrating on M2, no? Therefore, M2. So, M2G, normal force J is acting along positive y. M2G is acting along negative y direction. Therefore, minus J cap must be written. This one is equal to F net. Are you clear? Again, I will write Nj cap minus of M2G J cap, which is equal to, now you tell me whether the body is moving in this direction. Is there any acceleration? No movement at all. Therefore, instead of A, since no acceleration, we can substitute the entire value as 0. Therefore, Nj cap minus M2G J cap is equal to 0. Therefore, normal J cap minus M2G is equal to 0. I have removed the J cap. After that, these two becomes equal. Both will become equal finally. The normal force will be equivalent to M2G. So, both are acting in the opposite direction. Their magnitudes are same. So, they nullify with each other. So, no movement at all. So, for the movement in this direction, these two forces, they are not contributing anything. That is why I have written the expression separately. So, this part is not useful for our derivation. Just you keep it aside. Okay. Already we have derived these two equations. Okay, from the previous derivations, we have got these two equations. Now, the second equation that is to be substituted in the first equation. Replace this t with the help of this equation. Now, this M2A must be substituted here. So, therefore, M2A minus M1G is equal to minus M1A substituted. Now, what is required? Acceleration is required. So, to get the acceleration, what we have to do? Now, this A factors must be written in one side. Minus M1G is equal to minus M1A, or we can write, bring this factor here, minus M2A can be written. Change the sign. Completely you can change the sign. Are you clear? M1G is equal to M1A plus M2A. So, here A can be written as a common factor M1 plus M2 m1g can be written, to get A, bring the factor down, m1g divided by m1 plus m2. So this is the expression for acceleration. Here this body is accelerated, this much amount of acceleration is acting on the m2 body as well as by the m1 body. So this is a common acceleration factor. Are you clear? Now we have to calculate the tension also. To calculate the tension, we can use the common equation. Already we have found out. In the same expression, A must be substituted. T is equal to m2A. Substitute A here. m2 m1g divided by m1 plus m2 can be written. So finally you will get m1 m2 g divided by m1 plus m2. So this is the expression for tension. This is the expression for acceleration. Are you clear? So two expressions we have derived. I will block the expression of tension also. That is also very important equation. Okay. So this is the expression for tension. Okay. Now already we have learnt about the movement of the blocks in the case of horizontal motion, and we have learnt about vertical movement of the blocks also. Look at both the two expressions of the tension. Here the tension expression is 2m1 m2 divided by m1 m2g. Here in the case of horizontal motion of the blocks, the expression is T is equal to m1 m2 divided by m1 plus m2g. The only difference is here 2 is there, here 2 is not there. Are you clear? It shows that here just half of the tension is required. When compared to this one, half of the tension is required. The tension in the string for horizontal motion here is half of the tension for the vertical motion. Are you clear? For the same set of masses and strings. So here it shows that this particular expression is mainly used, and this application is mainly used in the case of industries. The rope used in the conveyors, mainly this kind of system, they are used in the conveyors. The ropes used in the conveyors, that is in the case of horizontal motion belt, conveyor belts, horizontal motion, so clear, they are working for longer duration. Are you clear? Because tension is less. This kind of system in which the conveyor belts are working for longer duration than those used for in the case of cranes. In the case of cranes, the system will be vertical. There also tension is acting. There tension is clear. Tension required is more. Here tension required is less. Therefore, the life of the conveyor belt in the case of horizontal conveyor belt is more when compared to this one. Okay.